Hello everyone and welcome back to Leetcoding. In this video we are going to be discussing the minimized deviations in array problem. So it's a hard problem and it is one of my favorite problem because this question is very easy to explain, that you will see later on, but yet very hard to wrap your head around, especially during an interview. So this is one reason, and secondly, this question has also been asked in some major companies like Amazon, Samsung, and one of my friend also got a variations of these questions during his on-site in Pinterest. So make sure to watch the entire video if you have an upcoming interview in any of those companies. So if you are ready, let's get started. Okay, so I will start with the problem statement. So it says we'll be given an array of integers like this one, and we have to return the minimum deviation d. Right, so what is the deviation? Deviation is the maximum difference between any two elements in an array. That means to get the deviation, we have to pick the largest and the smallest number. So if we consider the first example, we see the largest number is 4, right? And the smallest number is 1. Thereby the deviation will be 3, right? This difference will definitely give us a deviation, that's true, but that's not what the question is asking. You will see that the question is asking us to return the minimum one, right? And that's what makes this question interesting. It says we're allowed to use any of these two operations that you can see over here, and we can use it as many times as we want to make the deviations minimum. Okay, so now that we have discussed the problem statement, so before jumping to the actual solution, let's step back and try to visualize few things. These visualizations will ultimately help us to lead to the solution. So let's say, let me draw a line first. So this line represents all the number between 0 and 10. Okay, now if we also have to, so if we have to plot this array, right, this array, in this line, that will be like something like this, right? 1, 2, 3, 4, right? Let me change the color. Okay, now this green line represents the minimum, right? So this line actually represents the minimum, and we also need another line, and let's call it maximum, right? And between these two lines is the gap, right? Or the deviations that we are dealing with. So our task is to minimize this gap. That's what the requirement for this given problem. So how can we actually minimize this gap? So it's very simple, right? We either have to move this minimum number towards the maximum number, or we have to bring down the maximum number towards the minimum one, right? We can take both approach, but for this problem, if we take the maximum number and try to minimize it, then it will be a lot easier. To minimize this, we can actually use these operations, right? We can, so because this is a larger number, and if we can divide it, then it will come closer to the minimum one. So to summarize, what I'm saying is that we'll probably so to summarize, what we will be actually doing is we'll be manipulating this array with these two operations. And after doing that, we will actually try to figure out the deviations at every steps. So that is the main goal, and that is the main summary of the solutions. Okay, now let's jump into the code. So let me quickly write a high-level blueprint of what we'll be doing here, right? So at first, we will try to make all the numbers even, right? And the way we'll be doing is we'll be taking all the odd numbers into consideration, like this 1, 3, and then we'll simply be multiplying it by 2, right? So make all the odd numbers into even by multiply 2. Okay, and after this step we'll probably be able to calculate the deviations, right? Now this deviation that we got from number 2 is probably not the minimum one, right? And since all the numbers have already become positive, right, all the numbers become even numbers, so what we can do is we can divide all the numbers one at a time, right? As long there is some even numbers, we'll keep repeating the same operations, and in the end after each operation we'll try to recalculate the deviation. So divide the largest number by 2 and then recalculate the deviation. I think this is pretty much everything that we have to do, right, to solve this problem. So let me quickly start. Okay, so let me first define few variables. So mini, so that means the minimum integer, right? So let me quickly initiate with some default value. Okay, and then we will make all the odd numbers into even, right? So this is the first task that we need to do. Okay, so we can run a loop from integer I to 0, then nums.size I++, right? And within this loop we actually have to check if the nums of I is actually divisible by 2 or not, right? Because if it's not, then we have to multiply it with 2. Okay, after this operation what we'll be doing is we'll be updating this minimum variable and the maximum variable, right? Because in the end we'll be actually calculating the maximum deviations. So let's see, right? Here we can actually calculate this, something like this. So far what we have done is we have taken all the odd numbers into consideration over here. So if it's not divided by 2, we know it's an odd number, and thereby we have actually multiplied it with 2. So if we consider this example over here, so initially our list has 1 2 3 4. Now 1 is an odd number, so we multiply it with 2. Then 2 is an even number, so we skip that one. 3 is an odd number, so we multiply it with 2, it becomes 6, and 4 is already is an even number, right? So at this point, right, after this operation, what is the minimum number? The minimum will be like 2, right? It can be anyone, but so it can be this 2 or this 2, but that doesn't matter. And the maximum number is the 6, right? So what will be the deviation at this point? At this point the deviation will be 6 minus 2 is equal to 4. Okay, now what we'll try to do is to divide the largest number, because all the numbers are even at this point, right? So our target is to pick the largest number. But how can we pick the largest number? So one possible approach is to iterate this array one at a time, but that will be kind of costly. A better approach is to put all these numbers into a priority queue. Okay, so if we put everything in a priority queue, because we're putting it in a priority queue because we only care about the maximum numbers, we don't care about the rest, right? And priority queue can actually give us the top elements very easily. So that's what we're doing here. So we put everything in a priority queue. So let me quickly define a priority queue. So priority queue is nothing but a heap, right? Just in case if you don't know. and then we have to put all the elements from this nulls. Okay. Okay. Now we have actually placed everything inside this priority queue. So priority queue now have this 2, 2, 6, 4. Now our task is to pick the largest one. How can we get the largest one? It's very simple. We can just call the p2.top. This will give me the largest element, right? So what we'll do with this priority queue, with this number, we want to see whether it is still an even number or odd number, because it's still, if it's still a even number, right, then we want to, if it's still an even number, then we want to divide it by 2, right, and then we want to recalculate everything. So that's what we are doing over here. So let's call it eq.top. So at this point, max I hold this top element because this is the maximum number, and we will also remove this element, right? So initially our priority queue has 6 was the largest number, so we kind of remove this number from the priority queue. So this is what we have done, right? And then we'll actually try to calculate the deviations again, right? And we'll try to calculate the deviation, and we'll see if this needs to update it, right? After that, we will be dividing this number, this maxi, and we'll get a new number, right? So the new number will be something like maxi by 2. And then we can actually push this new number in the list. So this will be like 3, right? So this is what we have over here as of now. And then we'll also update the minimum number at this position. So once we have performed this operation for all the elements, right? So this 4 becomes 2, this 2 becomes 1, this 2 becomes 1. So once we are done doing all this operation, after that we will actually recalculate the deviation for the final time. Deviation, and this will give us the final result, right? Deviation. Okay, let me quickly check if I have made anything. Yeah, so I think everything looks okay. So let me submit. Okay, so it got accepted, right? Okay, so what will be the time complexity, time and space complexity for this question? So let me quickly talk about that, and then we'll wrap this video. So the overall time complexity for this problem is order of n log n, right? The algorithm involves inserting n elements into the priority queue in worst case, and that is why this is actually n log n. The space complexity is order of n, because in the priority queue needs to hold all the n elements. It's true that we have actually used certain variables like this mini, maxi, and this deviation, but those are actually constant, right? So the overall time complexity will still remain order of n. So yeah, so that's it for today. So thank you for watching. I'll see you in the next video.